there were two key areas of our green technological product and systems that I will cover today. The first one is on air pollution control, and the second one is what we call the Ecofeet cooling panels for building. Basically, it is a green tech air conditioning system, which is related to air handling. That's the reason why we include that into our product line as well. Okay, for air pollution control, there were a number of areas that I would like to cover. The first one is, I think the most critical part is this Environmental Quality Clean Air Regulation 2014. It was only recently gazetted in July 2014, and this is a very important new act. Can I have the copy of that? You know, our clean air regulations was first gazetted in the year 1978, and it has been for the last 36 years, no change. So it was only changed this year, July. So imagine that if the law has been there for 36 years, it was too old, and now we have a new gazette, new law, and this new law has actually changed the whole scenario very dramatically. The emission level, the emission limit now has been very, very stringent. They have covered more areas in terms of volatile organic compound emission, VOC emission, odor, the smell, and it also covered more industries like oil and gas industries, like the incinerator industry, like the mining industries, and so on and so forth, besides the manufacturing and the process industries. So I may cover a little bit. And this law will be applicable immediately for the new premises, for new expansion, and for new installations. That means to say that if you need to install any new production facilities that will generate any form of air pollution, you must comply with this new law immediately. That is the law, right? But for those premises or factories, existing factories that you already have been running, or for those installations on air pollution control that you have operating, and then it will take you about 5 years to comply. That means they give you a grace period of 5 years to comply. All right, just give you a bit of a sample of those new emission level for the, in this particular book, in this particular regulation. You can see that the regulations are now much more stringent than before. Give you an example, the biomass boiler that is fired with a fuel, solid fuel. Those that fire with the pump waste boilers, like example, the shell and fiber, the empty fruit bunch that you fire with wood dust, which rice husk waste, or sugar bagasse, and so on and so forth. These kind of boilers, in the past, the emission level was 400 milligram. 400 milligram or 0.4 gram. But today, you have to comply with 150 milligram per cubic meter of air. And you need also either periodic or continuous monitoring at the stack, at the chimney, right? To be sure that the DOE, the Department of Environment, want to be sure that you are able to comply with this emission standard. So you can see that it's very stringent. And the waste incinerator is 100 milligram. These are in terms of dust, only dust. They're not talking about gases. Gases, they have different set of regulations. The secondary aluminum melting furnaces, like the recycling of scrap aluminum, when you melt in the furnaces, the emission level now is reduced down to 10 milligram. Now this is very, very stringent. I have already received calls from aluminum companies that complain that this regulations is actually too stringent for them. But of course, it can be done, right? There are technologies and equipment available in Malaysia that are able to help you to comply with all these regulations. The electric arc furnace that you use to melt metal scraps in the in the steel plant, right? In a big steel plant, you know, like people like what they call Anju, this Prawaja, or Mega Steel, or Antara Steel, and so on, Southern Steel. These are the people that have a lot of electric arc furnace in their factory, and they have to comply down to 50 milligram, right? Cement kilns, 50 milligram, sorry. Dioxin and furan, these are the very toxic gases that will come out from plants like incinerator. You know, when you burn something, burn rubbish, or burn medical waste in an incinerator, it will generate dioxins and furan. These are very toxic. And you see the level is 0.1 nanogram. Nano is 1,000 times less than the milli. Right? After milli, 1,000 times less is nano. And it's 0.1 nanogram total toxicity equivalent per cubic meter. So this one practically almost zero. Almost zero. That means they don't allow you to emit any form of dioxin or furan from any form of incinerator. Okay, let's talk about the air pollution sources. Basically, it can come from 3 different processes. In any form of production facilities or factories, you will always come across either you will have some mechanical process or thermal process or chemical process. These are 2 major processes. Right? Mechanical means you can see that it's from crushing, milling, grinding, screening, conveying, tumbling, and so on. So during this operation, you generate a lot of dust. Now, in the thermal process, anything that has got to do with heating. Heating, melting, drying, curing, burning, where you use fuel to burn, you have burner. This burner or combustion system will also generate a lot of fine dust or fine fumes. Now, in a chemical process like coating, printing, laminating, galvanizing, electroplating, chemical reactors, this will generate also some form of dust, plus many other kinds of gaseous pollutants like the VOC, the volatile organic compound, which are quite difficult to control. Sorry, this is one more. All right. Now, what are the factors that we need to consider when you want to select or choose any type or form of air pollution control equipment? So these are the 3 major factors: environmental factors, engineering factors, and economic factors. So for bosses, they always think about this. The purchasing manager and the bosses, they always they look at only this, capital cost. But I would advise you to look at the operating cost, the maintenance cost, the life cycle cost. Because an air pollution control equipment is a very expensive expenditure, capital expenditure. And normally this kind of system can last you more than 10 years, 15 years. We have installations that have been running for the last 30 years. Because we started the business in this field in 1983. So it's 31 years. So there's still system running. So you can see that this is quite important for the bosses. Whereas for the engineers, they will look in all this. These 2, the gas and stream characteristic, dust loading, particle shape, size, corrosivity, toxicity, the air volume required, the type of air pollution control equipment, and for the environmental factors, we will consider all this. So, as a designer or as an equipment manufacturer and supplier, we will have to consider all these 3 factors, right, in order for us to give you an effective and very efficient kind of air pollution control equipment. All right, as I said, the air pollution control considered factor will be mainly, number 1, we must comply with the regulatory codes and the emission standards, now especially related to Environmental Quality Clean Air Regulations 2014 since July this year. So we have to comply with the new law, new emission standards, and we must make sure that we are able to offer the lowest cost. Lowest cost is a combination of these 3 combined together, and then this will be the choice of equipment. Of course, plus other consideration factors like the company background, the experience, the kind of after-sales service they are able to provide, and so on. I will just bring you through some few procedures and the methodology of industrial air pollution control. This is just for your reference, so that you understand that how do you go about choosing or selecting the right type of air pollution control equipment. So these are basic principles. So at first you must study the source. You must know what is your problem, right? Where is the source of air pollution? What type of air pollutants are coming out? How, where, what, when, and so on, right? This is very important. And you have to identify, why do you want air pollution control? Why? Because air pollution control means money. It means spending money, right? So a lot of people say, no need. Basically, the main reason here is to comply with the law, comply with the clean air regulations. This is one of, I would say, the key reasons for the industries to go ahead to install air pollution control. There are many other reasons, but this is the key reason. And you need to study and analyze the air pollutants and the contaminants very thoroughly before you come to any kind of selection and sizing of the equipment. And you need to know how to remove the contaminant, how to exhaust it out from the source using the local exhaust ventilation principle. We call it LEV. In the DOSH term, the Department of Occupational safety and health, they have this terminology called LEV, local exhaust ventilation. So we have to comply with their requirement as well. And then you talk about how are you able to convey and transport the pollutants from the source with via the suction hoods through the ducting to the pollution abatement equipment and eventually to the fan and to the chimney. So what DOE want to see is what is coming out at the chimney, at the stack. That is the most important, because this is where they will take the measurement of the emission level, whether you're able to comply with the rule, with their emission standard. That's what we do at the chimney. Huh? And after you have collected or removed the air pollutants, right? Now, how are you going to discharge the of the dispose the contaminants? You cannot simply throw away. So you have to decide, so determine whether the pollutants or the dust that you collect, are they actually toxic? Are they considered or rated as scheduled waste? If they are rated as scheduled waste, then you cannot throw. You have to record, you have to store it, and you have to get a licensed contractor, licensed by the DOE, to collect and then move it to Quality Alam. At this moment, Quality Alam is the only company that can treat the toxic waste or scheduled waste, industrial scheduled waste. So again, the disposal will cost you some money, right? And also at the same time, you also think, now, do you want to recycle the air? Do you want to return the air back to your workspace? Now, for example, if in the electronic industry, there are a lot of pollutants that are generated within the air-conditioned space. So when you suck the aircon air out and throw it out to the atmosphere, you're losing the aircon air, right? That means the air conditioner has to be sized bigger and you have to work harder. So which means that you have to think whether you want to recycle the air back. So you need to recycle it back, then we need to have a separate or secondary treatment for the air. Then finally, I think the most important of all is, of course, this: what kind of air pollution control equipment you're going to select to ensure that you comply with the law, with the emission standard. At the same time, it gives you a very long lifespan in terms of operation, the low cost of operation, the low cost of maintenance, and so on. Okay, this just to give you one example of a typical one of the installation that we've done some years ago for the brass melting plant. You can see this is a brass melting furnace. This is a source of air pollution. The source, then you suck it through the hoods, go through the ducting system, long ducting system, go through some different types of air pollution control equipment. You see you got settling chamber, you got cyclone, you got air cooling, finally to the back filter dust collector, eventually to the fan, and out to the chimney here. All right. So here, this is what we call an air pollution control system, comprising different kind of components, different type of components here. Right. So you see the design. If you design one of them wrongly, then I think the whole system will not work. So this is quite important and quite critical. This is a typical example of a big steel plant in the electric arc furnace. You can see from here. This is electric arc furnace, melting scrap metal, right? So Mr. Lau, your scrap metal, you send here to be melted, and during the melting process, it will generate tons of dust, tons, you know. There will be a lot of complaint from the residents and the surrounding factories, because if your system is not running well, then you got a big problem. Right, so you can see from here, there are big hood on top of the roof, and you have got other secondary suction. So you see, you have the cooler, you have the dust collector, you have all the ducting system, you have the big fan. Sorry, what happened to it? 3 big fans. You know how big is this fan? Just for your knowledge, for your info. Each fan is rated at about 1,500 kilowatt. So you have 3 fans, 4,500 kilowatt. 4.5 megawatt. So this is a big consumer of power. So air pollution control need big fan, big blower, a big motor. Big motor. Bernard Fong, you can sell the big motor there. And you need a big frequency inverter to control the speed. So this is where the control comes in. And then the chimney here. Right? And this one you now have to comply 50 milligram. That means whatever you suck here, right? Whatever you suck, all this dust come out from here, has to go through the whole process. But at the end result is what? The end result is you must make sure that you have less than 50 milligram coming out from this point. the chimney point here. And you have a monitoring port, we call it the sampling port at the chimney, where the DOE officers can go up there and take the measurement. Or the third, what do you call, the lab company can go in and take a sample of the dust, and they go back to the lab and take a measurement and a weight. Then they can calculate what is the emission level. So if your report shows more than 50 milligram, sorry, the whole system failed. Right, then you have to redo. Okay, so what we mean by efficient air pollution control system. So these are all the factors that you have to consider. Start from the design, then the emission level, the suction hood, the ducting, the air pollution control equipment, the fan, the pollutant disposal. These are all the factors that you must consider in order for you to be able to achieve the efficient air pollution control system. Okay, so the aim for a designer or for the manufacturer of air pollution control equipment or the contractor or supplier is this. We must make sure that everything is small. Why? We want to bring the cost down. To arrive at the optimum design, everything small. Small fan, small motor, small equipment, small flow, small ducting, everything small. But if you are too small, then you become undersized. Once you're under capacity, the whole thing cannot work. So that's why we talk about optimum, right? Small but optimum. Okay. Effective. What is effective? Effective means the equipment and the system runs smoothly. No trouble, no stoppage, no electrical disturbances, no mechanical disturbances. You know, suddenly after running for a while, the fan shake, vibrate, the motor stops, right? So we must make sure that the system will run continuously. Now, most of the air pollution control equipment and system, normally they will run 24 hours, 7 days a week. Sometimes they even run 365 days, non-stop, right? So imagine that this equipment is critical. That you must make sure that it is able to run on a continuous basis, and it must be sustainable. Because their equipment can run continuously for 1 month, then the second month they break down, right? Then they become no more effective. Optimal suction. So the suction must be strong enough to remove all the air pollutants from the source so that there is no escapement of the dust or fumes or gases out of the area. But it shouldn't be too strong. We have seen suction is so strong, when you go near, your clothing gets sucked inside, the hair gets sucked inside. That's not necessary. Then you're wasting your energy, right? But it must be strong enough suction. There will be no dust choking the duct. There's a lot of problem when the duct gets choked. No more suction. The duct will also collapse because it's too heavy, right? And no clogging of the back of the air pollution control equipment. Sometimes the whole equipment gets choked or blocked. Then the whole thing fails, right? And low maintenance cost, and it's what we call effective. So again, first thing, you must meet the DOE standard, the DOSH standards. This is number one. Number two, low running costs, continuous running without problem, no complaint for operator or neighbor, longer lifespan, right? That's what we try to achieve. Okay, so I said how to achieve effectiveness and high efficiency. So you can see from here, you must study the process, the production operation, the characteristic of the pollutants, and so on and so forth. These are very thorough investigation of the process before we come up with the design. So I think this is our job. As a designer, this is our job to do that. What you need to do as a production unit is you just tell the designer or the supplier your problem. Tell them your problem, they will solve it for you. So then we talk about the system design, the control equipment, the operating instruction manual. This is very important, that to make sure that the plant is able to run well. We have a logbook or record for the operator to record all the important parameters and the data so that they know, whether the plant is running well or not. And you have preventive maintenance, performance monitoring. This is already a must now, required by DOE, that you have to do your own internal monitoring system for the equipment. Okay, now we go to different type of air pollution control equipment. These are all the equipment that are available in Malaysia. The technologies are available, and you have no problem to source or look for this kind of equipment here locally. You don't even have to look out of Malaysia. I mean, a lot of our clients always think that the Malaysia standard is very backward. You know, we are not able to catch up with the European world or the advanced countries. But actually, it's not true. We already have all this equipment here locally. You know, especially within our company, we have all this. You can see that we start from the basic one: settling chamber, cyclonic separators, bag filters, electrostatic precipitators, wet collectors, oil mist filters, Venturi, scrubbers, dust suppression system for dust and particulate control, meaning to say that if your pollutant is comprised of dust or dry particulate matter, then you can use this kind of equipment. But if it is a wet, or if it's in a gaseous form, it's a VOC or odor form, then you have to use different type of equipment like gas scrubber, activated carbon tower, biofilter, solvent recovery, regenerative thermal oxidizer, and so on. Right? So these are two different sets of equipment. Okay, these are just some basic sketch to show you the principle of what is a settling chamber. I don't want to go into detail. Can be a bit technical, but I think you know. The dust come in, and then goes out. So dust drop down here. But this one only can cater for very big, heavy, big particle dust. Right? Not for small one. Right. So this is a better equipment than the settling chamber, which is called a cyclone, or you have multi-cyclone. In the case of boiler, biomass boiler, you use multi-cyclone. That means you use many cyclones combined together. Right. So the principle is, again, using a centrifugal force, right, to rotate the dust and the air in a volute form, and the dust will go out and throw out in the internal wall of the body, and then goes down. See, the dust is collected here. Sorry, this is no good. And then eventually, the fine dust will still go out. So the outside here, there's still some dust. This equipment is also meant for coarse particles, not for fine particles. Okay, this is the best bag filter dust collector. The most efficient, the most popular, and the most commonly used air pollution control equipment is bag filter dust collector. They are able to comply with very stringent emission standard, right down to even 5 milligram. There's no problem. That's why I said if our law here says that you need to comply by 10 milligram, then this equipment would be able to solve it for you. So we can design the system to meet down to 10 or even 5 milligram. We have done that before. All right. So you can see from here, there are different type of system. You have fabric, woven, needle felt, spun bonded, shaker type, pulse jet, reverse. The most common one that we use nowadays is the pulse jet. The shaker and the reverse are old technology. They have been there maybe since the 50s, 1950s, 60s, and so on. But the modern type of bag filter dust collector today, we are using pulse jet, because this is the most efficient and what they call modern. All right, so you can see from here, the most common equipment, very widely used, very high collection efficiency, can go up to 99.9, even 99%, right? And the dust can be recovered dry. You can recycle the dust. You can reuse the dust. You can even sell it. Sometimes the dust has got value. For example, in the cement industries, they collect the dust. Dust is their finished product. So they cannot afford to let the dust go out of the plant. That is money to them. Right? Those in the lime industry, those in the gold. I remember about 28 years ago, I sold a plant to a gold jewelry, jewelry processing factory in Penang. It's a German factory. I went in, I said, wow, you got so much dust on the floor. They said, no, this is not dust, this is money. That time the gold price was not as high as now, you know. Then he said, can you quickly install a system for us? Because every day we're losing money, you know. So we work out for them, after we install, how much the gold dust they collect. Actually, the payback period for the installation takes them, I think, less than 3 months. Within 3 months, the capital cost is fully recovered because there's money. You see? So they said, make sure you give me a good system and maintain it for me well, because what you're collecting for us is money, not dust. Okay. This is electrostatic precipitators using electrical charge principle. That means the dust are electrically charged, and then they will be negatively charged, and they will be collected on the collecting plate. And as the gas stream goes through, the dust are removed here, and when it comes out, it's clean gas. Now these are for very big installations, like in the power plant, in a big coal-fired power plant, in the incinerator plant, in the metallurgical industry, the very big one. These are huge installations. But in Malaysia, we don't use this so often. All right, electrostatic principle, as you see from here. All right, higher capital cost, big airflow, big plant, cement power plant. Now, even in the cement plant, the efficiency of the electrostatic precipitator is getting not good enough. So we have cases where a lot of cement plants now are trying to convert from electrostatic precipitators to back filters. Electrostatic precipitator probably can go up to about, let's say, the best they can do is close to maybe 50 milligram. That's the very best they can do. Most of the time they go up to about 100 milligram. But if you want to reduce it to 20 milligram or 10 milligram, then ESP is out. So you have to convert it. We can convert it back into the back filter. That means you can use this chamber, but inside we remove all the collecting plates and replace it with the filter bags. So that can be done, the conversion process. Now, if you have a wet dust, or hot, wet, sticky, oily dust, then the back filter is out. You can't use the back filter because the back will be choked, right? Because when the oil is sticky, the dust come in, it form choke, the whole cake on the bags, and you can't remove it. So in this case, you have to use a Venturi scrubber. So this is the Venturi, right? The dust go through with the water spray, and then you've got a cyclonic separator, and then the clean air goes out. This is another type of equipment. Then if you have gaseous, the Venturi scrubber can be used for removing of particles as well as gas. But for gas scrubber, it's purely for gas. For example, you get ammonia gas, chlorine gas, fluorine gas, hydrogen sulfide, and so on and so forth, or SO2 or SOx, SO3. Then you should use this kind of gas scrubber, right? Where the contact of the gas and the air and the water in the counterflow direction, the gas is going up and the water is flowing down. So there is a sufficient contact time or residence time for the water to react with the air or to absorb the air pollutants in the airstream. So when the air goes up from the top here, it's clean air. So all the gases will be removed. This is another example of a gas scrubber system. Of course, the disadvantage of this is that you are actually converting air pollution into water pollution. So when you use gas scrubber, your slurry at the bottom, right, is full of gases and acidic gases or alkaline gases, and you need to discharge this to a wastewater treatment plant. Otherwise, you can't. Oh my God. Sorry, I have to hurry. Wet scrubber, almost 1 o'clock already. Okay, the activated carbon tower is also meant for VOC and smell. This is the latest one, thermal oxidizer. This is a very important equipment. We have installed this thermal oxidizer in Singapore last 2 years ago in an aircraft engine manufacturing plant called Rolls-Royce. You heard of Rolls-Royce, right? Rolls-Royce. It's not car, it's the engine. It's the aircraft engine. So we are very lucky that we were invited into for this project, and eventually we won this project. We were awarded with this project, and we did supply thermal oxidizer to this particular plant. So it's a very prestigious project for us. We are very lucky that the Rolls-Royce look out on us. Okay, different type of thermal oxidizer. You can see we have direct thermal, recuperative, catalytic, regenerative. These are a bit technical, so I don't have much time to do it. I presented this very thoroughly to the Rolls-Royce team before they select us, because they want to know how much knowledge you know about thermal oxidizers. And we were lucky that we have a technological partner from US. So that's why we, together we went in and we won the prize, won the order. Okay, this is about the current biomass boiler emission control. You can see from here, this is what is happening now. All the palm oil mills and so on, for the boiler, they're using this multi-cyclone system. But you cannot meet the current regulation. The old one is 400 milligram, but the new one is 150. So what you do is, you have to add on extra equipment after the multi-cyclone in order for you to achieve the 150 milligram. All right? Okay, so this another one you can achieve. Now we say here we can even achieve less than 50 milligram. There's no problem. The law calls for 150, but we are able to achieve even 50 or even below. If you said, can you reach 10 or 20? No problem. We can always do that. Huh? So it's up to you individual whether you want to have a very stringent control. Now the performance monitoring is very critical. That in order for you to have a long lasting of the equipment, then you should do this. Different stage, design stage, construction stage, operation stage, and so on. Right? And this is required by DOE. It's already compulsory. It's a law, and you have to have competent person in order to operate the air pollution control equipment. We are conducting certified training courses for air pollution control operators, air pollution control technicians and engineers, and so on. So this is a certified course by the Department of Environment, and Master Jaya is doing all this training. Okay, this is performance monitoring. Again, you can see that this is a requirement by the Ministry of Environment since 2007. Okay, performance monitoring. Again, these are all the equipment that you need to do the performance monitoring. Okay, this is a little bit about our company. It's our office, and this is our factory in Nilai. Well, why Master Jaya? A little bit of airtime. We are your most reliable, responsible, and competent partner in air pollution control because we are your one-stop center. Total solution provider for air pollution control. And we have done more than 1,000 air pollution control systems all over Malaysia and ASEAN countries. And we have been exporting to various countries over the last 10 years. So, and we have 30 years of proven track record. This is our scope of business. You can see we are one-stop center, you can see. From the study, design, consultancy, all the way to training and so on. The whole lot. Any air pollution problem, you come to us, you stop there. Then we will solve it for you. That's it. Okay, think green, sustainable. Okay, give me about another few minutes to talk about Ecofeet. This is the new way of air conditioning system. We call it the green aircon system. Using the Ecofeet. Ecofeet is our principal, our friend Benedict is here. He's from Ecofeet Singapore. And this belongs to a very big group, SGL Group, the carbon electrode manufacturer. You can see this building here, this ceiling here, they are all equipped with the Ecofeet radiant cooling panel. You don't see air, no air. The air is only meant for ventilation, a very little amount of air. But there's no air blowing down to cool you. So you don't have cold spots. You have very even cooling and no noise. No noise because there's no draft. All right? Okay, Ecofeet. Okay, and very energy efficient. We can save energy up to about 30%, 31%. So this is a very energy cost saving kind of a system. You can see the panel here, this one. This is to replace your ceiling panel. You know, your ceiling panel, it can be used for ceiling or even used as a wall, where you have the chill water going in to cool the panel. And because of the radiant cooling effect, the whole space is cool without air flowing, without the noise. No noise, no cold spots, no dust swirl, no draft, no noise, and the increase of thermal comfort. You feel very comfortable. Now this is one of the installations that we have done in Singapore. NTU, Nanyang Technological University, has been running for the last 2 years now, and it's proven that they're very happy with that. I can see from here. This can be used for hotel, offices, all kinds of building, hospital, where you have very stringent requirement for noise level, for very even distribution of coolness, and no draft. Right? You don't have to worry when you go to a restaurant, oh my God, the aircon is on top of my head. So you try to move yourself, right? But with this system, you can sit anywhere. No worry about draft. No draft dropping onto your head. Okay, this is radiant cooling. We say radiant. This is radiant. Huh? So this is the way that the energy is transmitted, the coolness or the heat is transmitted through radiation. All right, you can see this is one of the examples of the installation, the cooling panel. All right, you see here? All right, it's hidden there. Somebody knocking the wall, I know. Okay, coming soon, okay? All right, you can see the energy saving here, 26%. This is This is taken, the figure is taken from NTU, Nanyang Technological University in Singapore. Okay, this is the exact the building. You can see on top, these are the panel with our cooling system on top in the ceiling. Okay, these are the cooling solutions. All right, this is our contact. Thank you very much.